We're talking about the product rule today, and basically what the product rule does is it helps us take the derivative when we have two functions multiplied together. So you see these two functions here, x squared is a function, x to the fifth is a function, they're multiplied together. And we want to find the derivative. And we know how to find this, right? We know how to find this. We would just multiply them together, which would give us x to the seventh, and then we would take the derivative, f prime of x would be 7x to the sixth. But some people, even in our last chapter, wanted to just take the derivative of this and multiply it by the derivative of that. So let's see if we can do that. So if I take the derivative of 2x, I would get, of x squared, I would get 2x. And if I take the derivative of 5, see, I keep ahead of myself, x to the fifth, it would be 5x to the fourth. So what would I get? I would get 10x to the fifth. Are those equal? No. And we know this is the answer. We know, absolutely know, that that's the derivative. So can we take the derivative of two functions and then just multiply them together? No. And the reason we can't, the reason we know we can't is because if you find one example where they don't work, then it's never a rule, right? So this is just one example, but you couldn't do it with any functions, okay? So how do we find the derivative of two functions multiplied together? Because sometimes we can just do algebra to combine them, but there's some functions, and you don't know how to do this one just yet, but what if we had sine x times cosine x? We can't just combine them, right? And so we have to figure out how to take the derivative of something like that when we have two functions multiplied together. So the product rule comes down to this. Fig plus gif. That's it. You just have to remember fig plus gif. So I'll write this out in actual mathy terms. So the derivative of some function f times some function g equals the derivative of f times g plus the derivative of g times f. Do you see how this kind of looks like fig, gif? That's how we remember it. And so what I always do with every derivative when I'm trying to do the product rule is I make myself a little table. And here I have f of x, and here I have g of x, and then here I'm going to have f prime of x, and then I'm going to have g prime of x. Okay? Now, then I can just find all of those, and then I can use it to multiply. So then I would multiply diagonals. Fig is these two multiplied together, plus gif, which are these two multiplied together. So let's look at how this actually works. Here is the actual mathy stuff. Mine doesn't turn out very nicely, but on your book it shows perfectly. That should be multiplication there, but other than that, okay. So fig plus gif. This one's in a little bit different order. And then the quotient rule. So the quotient rule is when we have two things divided by each other. So if I have the derivative of f of x divided by g of x, I have low d high, okay, so that's the lower function times the derivative of the upper function, minus high d low, square the bottom, and away we go. So this is how you're going to remember it. Low d high minus high d low, square the bottom, and away we go. Okay, so bottom function times the derivative of the top minus top function times the derivative of the bottom, and then we square the bottom function. Okay, let's practice. So we're going to differentiate these two. Now you look at a function like this and you think, oh, well, you could have used algebra, right, to multiply all of these out. You could have done that. There's going to be a lot of functions where we absolutely just can't, or we have to use the product rule. But in last chapter, we would have just FOILed this out. But let's go ahead and do the product rule with this. So first I'm going to make myself a little table. We'll do it like this. I'm going to have f of x here, f prime of x there, g of x here, and g prime of x there. Okay, so f of x is, we're just going to name either one of them. So 3x squared minus 2 is f of x, and 2x plus 3 is g of x. So now I take the derivative of f of x, which is 6x, and the derivative of g of x is 2. Now I do fig plus give. So fig is these two multiplied together. So I have 6x times 2x plus 3 plus give. So that's 2 times 3x squared minus 2. So I have 12x squared plus 18x plus 6x squared minus 4. So I end up with 18x squared plus 18x minus 4. So that is, I should make this complete. F prime of x equals that. That's it. So what we could have done is we could have multiplied all of these out with FOIL, right? And then we could have just taken the derivative of each term individually. When you have something like that, it's your choice. There are going to be some that you just don't want to do that because it's like to the power of 5 or something like that. Okay. Here we have a quotient, and we need to find the derivative of this quotient, okay? So, again, we have to use the quotient rule because we don't know how to divide all of this. So, let's make ourselves a table. We'll have f of x up here, which is 2x squared minus 4x plus 3. And then g of x is 2 minus 3x. Okay, so then f prime is 4x minus 4, and g of x is negative, or g prime is negative 3. Okay, so we got to go low d high minus high d low. So purple is our high and green is our low. Okay, so low times the derivative d high, right? 4x minus 4 minus high. Make sure you put all of these in parentheses because you're multiplying the whole thing together. Okay, low d high minus high d low. Square the bottom and away we go. And you are done. Because in calculus, we don't always have to simplify. If we needed to simplify this, we could go further and further with it. But that is, and I should be more precise, y prime equals that. Okay. Here we have another one. We're going to rewrite this. Now, when you rewrite this, make sure you're not differentiating and rewriting at the same time, okay? Because that's a big mistake a lot of people make. Let's just rewrite it first with a negative exponent, then differentiate. So we're going to rewrite this as 9/5 x to the negative 2. And now, do we need a product or a quotient rule on this one? No. You see the quotient and you think, ooh, I need to do the quotient rule. And I'll show you how to do the quotient rule in a minute, but let's do it the way we know how to do it first, right? Okay, so we bring the negative 2 down, and I have negative 9/5 times negative 2, x to the negative 3. And so then we have negative 18/5 x to the negative 3. So that's y prime. Now to do the quotient rule, we don't need the quotient rule on this one because this on top is not a function, okay? I mean, it's a constant. But because it's a constant, we don't absolutely need the product or the quotient rule, but we could use it if you really wanted to. So we would do low d high, the derivative of a constant is 0, minus high d low, square the bottom, and away we go. So that becomes 0. That becomes 90x over 25x to the 4th, which gives us 18 Oops, I had a negative there. That would be 18/5 and the x cubed on the bottom. See how it came out to the same thing? So whenever you see a quotient, don't automatically just do the quotient rule. We only need to do the quotient rule if both of them are functions, meaning both of them have x's in it. If you see something where it's a constant on the top and a function on the bottom, we could just do what we used to do and move them up.